Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at a special kind of reaction called the halogen displacement reactions. So in our previous lesson we looked at the halogens. What we're now going to do is have a look at a very specific reaction for our halogens, the displacement reactions. So hopefully by the end of today's lesson you're going to be able to describe these displacement reactions and explain what's likely to happen and why. To start off though, we've got 4 questions here based around our previous lesson, so have a go answering these 4 questions in your book for me. So I'm going to give you about 4 minutes to do that. Okay, let's check those answers then. So the first one, group 7 are also known as the halogens. Give yourself a tick if you got that right. Diatomic means that the molecule is made of 2 atoms. Tick for that one. The formula for a chlorine molecule is Cl with a little 2 to the bottom right obviously a capital C and a lowercase l. And then for question 4, we've got 4 marks available. First one is if you said that as you go down the group, the halogens get less reactive. Second mark is for saying that the outer shell electrons are further from the nucleus the further down the group we go. Third mark is for saying that the further from the nucleus the outer shell electrons are, the weaker the force of attraction between the nucleus and those electrons will be. And the final mark is for pointing out that that's going to make it harder to gain the required electron. So, total of 7 marks there. Give yourself a score out of 7 in your book. Before we go any further in today's lesson, what we need to know is a very important definition, and that's for the word halide. Whenever we talk about a halide, that is a compound of a halogen and one other element, and usually that other element is a metal or it's hydrogen. So anytime we see the word halide, we're talking about a compound of a halogen with one other element. What we're going to be looking at then is a type of reaction called halogen displacement reactions. Now, in a displacement reaction, what we actually find is that a more reactive halogen will displace a less reactive halogen from the halide. So if we've got a more reactive halogen just in our mixture, and then we're going to add that to a less reactive halogen in the form of a halide, then what happens is the less reactive halogen is pushed out of that compound and the more reactive halogen will take its place. So make sure you've got those 2 sentences written down for me first of all. So what we've got at the top of the screen then, that is a balanced symbol equation for one of these displacement reactions. So we've got chlorine in gas form, and we're going to add that to the chemical sodium bromide, the halide. What we then form is sodium chloride and bromine. So what I'd like you to do is write down the balanced symbol equation first of all, and then see if you can have a go at answering the question underneath. Why does chlorine displace bromine from the bromide? hopefully what we wrote down is that chlorine is more reactive than bromine. That should be our first point, because if we think about the halogens, chlorine is above bromine, it's closer to the top, and the closer to the top of the group they are, the more reactive they are. So chlorine is more reactive than bromine, and that means it's going to then displace the bromine, because that's what happens when we react a more reactive halogen with a less reactive halogen in the form of a halide. It takes its place. First thing I'd like you to do then is to copy down the table at the top of the screen there. Now this is the table of results that we would normally be doing as a practical in class, and usually afterwards we then write the correct answers in because something hasn't gone right. But what we actually have today is a video of the experiment working perfectly, so we're going to get a perfect set of results this time. So copy the table for me first of all, and then what I'd like you to do is write me a prediction. So I want you to look at those chemicals and predict which experiment will show a change. And then I want you to explain why you think that. Before we get on to that though, I'll just give you a quick overview of how we carry out this experiment normally. Now in the lab you'd have one of the little spotting tiles, so those little white tiles with the little dimples in them. And what we then do is you'd place a few drops of your potassium chloride into one well, potassium bromide into a different well, and potassium iodide into a third well. So we'd have a little line of them. One well potassium chloride, next one potassium bromide, next one potassium iodide. Then what we do is we get some chlorine water, and again using a pipette, you then add a few drops of the chlorine water to the potassium chloride, and we'd be looking for a colour change. We'd do the same thing with the potassium bromide and potassium iodide with our chlorine water. Now once we've done that, we'll either put a tick or a cross in the box on our table there just to represent did we see a colour change or not. And then we do the exact same experiment, but instead of chlorine water we use bromine water and then iodine water. So we do it with 3 different sets of chemicals. Now the one key thing to bear in mind when we do this, a bit of safety, we are using things like chlorine, and hopefully we do know from our bit of history knowledge that inhaling large amounts of chlorine gas is a pretty bad idea for your longevity. So we'd make sure that we'd be very careful not to inhale large quantities of the fumes, usually doing this in a lovely ventilated area. So table first of all, because we're going to watch a video and you can fill that in a moment. And then once you've got that, predict which of those experiments will show a change and why you think this. So I'll give you a couple of minutes to get that done. Okay, so what I'd like you to do then is, as we watch the video of the experiment, if you see a colour change, put a tick in that box. If there's no colour change, put a cross in the box. So the first thing we're doing is we're adding our solutions of our potassium chloride, potassium bromide and potassium iodide to our test tubes in this case. What we're now going to do is start off with our chlorine water. So here's the chlorine water, and using the pipette we're just adding a small quantity to our potassium chloride, potassium bromide and potassium iodide. Now hopefully we can see that there was a very noticeable colour change for some of those tubes. Same thing with our bromine water this time, into the chloride, the bromide and the iodide. And again, hopefully you can see a very clear colour change for one of those tubes anyway. And then finally the iodine water to our 3 tubes. So do note that that's already an orangey colour to start, so we've not seen change. Now hopefully our table looks something like this. So what we saw in the video then was that when we added our chlorine water, then both the potassium bromide and the potassium iodide showed a really clear colour change, whereas the potassium chloride didn't. Then with our bromine water, the only one to show a clear colour change was the potassium iodide, and when we added the iodine water, there was no colour change in any of those tubes. If you don't have those correctly in your books, then please correct the results now, because that is really important that we have the correct set of results. What I'd like you to now have a go at doing is answering the question underneath. Explain what you would expect to see if we added fluorine and if we added astatine to our 3 test chemicals. So same experiment, but we're going to do it with fluorine and then we're going to do it with astatine. So see if you can predict what we would see there. So hopefully when we looked at the fluorine, we said that we'd expect to see a colour change with all 3 chemicals. And the reason for that is that fluorine is found above all 3 of those in the group 7. Therefore it's more reactive than all 3, so we'd expect a displacement to take place. Whereas for astatine, we'd have expected no changes at all because it's less reactive than all 3 chemicals. Obviously tick the answers you got right. If you didn't, then make sure you write in the correct answer. Now, the last part of this that we need to understand is how we can use half equations and ionic equations. When we talk about a half equation, quite simply, we use these to model what happens to each of the reactants that's involved in a chemical reaction. So if we consider one of our examples where we've got our chlorine reacting with our potassium bromide, then what we start off with are two half equations, one for chlorine and one for our bromide ions. So if we look at our chlorine first of all, the top one, we start off with chlorine, which is a diatomic molecule, Cl2, and in order to form chloride ions, each chlorine atom has to gain one electron. Because we've got two chlorine atoms, we need to add two electrons, hence the plus 2e minus, because e minus is the symbol for an electron, and that will then form two chloride ions, Cl minus. And if we go back to what we did previously on oil rigs, so oxidation is the loss of electrons, reduction is the gain of electrons. Because our chlorine atoms are gaining electrons, then it is a reduction reaction. If we now consider the second equation there, we've got our bromide ions to start with. So we've got Br minus, the bromide ions, and they're going to form bromine. Now bromine is a halogen, therefore it's a diatomic molecule, Br2, and we're also going to be releasing two electrons here because each bromide ion has one extra electron. So when it then forms the bromine, it's going to obviously get rid of those two electrons. So what we have are two bromide ions, 2Br minus, is going to make one molecule of bromine, Br2, plus two electrons, 2e minus. And because in this case we're losing electrons, then oxidation is the reaction, because oxidation is the loss of electrons. So we've got our two half equations at the top there. Then for the ionic equation, we put them together without the electrons, because the electrons cancel each other out basically, so we ignore them. Now what we actually have in our ionic equation is we start off with our chlorine, Cl2, and we've got our bromide ions, plus 2Br minus. Then on the other side, we're going to have two chloride ions, 2Cl minus, and one bromine molecule, Br2. And because we've got both the reduction for the chlorine and the oxidation for the bromide happening at the same time, we've got a reaction called a redox reaction. Reduction and oxidation at the same time. So I'll leave this up just for another minute and a half, just to give you a chance to write it down if you were just listening at that time. And then what we'll do is I'll give you a chance to have a go at writing some of these yourself. So 2 to have a go at. What I'd like you to do is write the half equations first of all, and then the ionic equation. So you're going to have 2 half equations and 1 ionic equation for each of these 2 reactions. So I'll give you a few minutes to have a go at this. Okay, let's check those answers then. So question 1, chlorine displacing iodine from iodide ions. So the first one is going to be the same as our example. We've got chlorine, so we start off with Cl2. That's going to gain 2 electrons plus 2 E minus to make 2 chloride ions, 2 Cl minus. And that is of course a reduction because it is a gain of electrons. Then we've got iodide ions, so 2I minus, and that's going to form I2 plus 2E minus. And that will be an oxidation because it's the loss of electrons. When we put it together to the ionic equation, it will be Cl2 plus 2I minus makes 2Cl minus plus I2. And again, that is a redox reaction. So obviously give yourself a mark out of 3 for question 1 for me. For question 2, bromine displacing iodine from iodide ions, then we're going to start off with our bromine, Br2, and we're going to gain 2 electrons there. So Br2 plus 2E minus makes 2Br minus, which is reduction. Then we've got our iodide ions, 2I minus, making I2 plus 2E minus. So that's the oxidation. And then when we put it together to the ionic equation, it will be Br2 plus 2I minus makes 2Br minus plus I2. And again, that's a redox. So give yourself a mark out of 3 for question 2. Last thing for today then is the plenary. So those of you with target grades up to grade 5, it's the questions on the left. Those of you with target grades over a grade 5, it's the questions on the right. So I'm going to leave these up for about 3 minutes today, but as always, if you need more time, just hit pause and take as long as you need to answer those in your books.